Okay, so this is a preliminary solution to our core.async implementation. We already get a feel of what is possible here. We can do better than this, more elegant, and leverage more of the capabilities of core.async. The main thing is that we will do something smarter. We will, instead of putting all the results in one channel, every request will use its own channel. So channels are very inexpensive, and there is no reason not to leverage that. So for every page, we're gonna fire a request that will asynchronously put the results in its own channel. So we'll have as many channels as there are pages. And that makes a lot of sense. This is how Core Async encourages you to work with channels. Okay, so let's see how that works. So here I'm going to define a function which will receive a page, and this one will create its channel. And then I call a find query here, and I return the channel here. So this is my function. And now I'm going to call this function on all the pages. And I'm going to collect those channels, because remember this function returns a channel, and I'm going to collect all the channels. And for now, I'm going to return the channel just to show you what is going on. So you see, now the results are the channels. Now, what I'm going to do with these channels is, and this is what I meant with core-async being a composable abstraction, or an abstraction that gives you means of composition, is that you have these operations that know how to work with channels all along. The usual functional operations like reduce and map and stuff like that. So we're going to do this. I'm going to feed those channels into a merge. And so this will take all the channels and merge them into one. On this one, I'm going to call reduce. I'm going to conj them in a vector. And this is what I'm going to read. Okay. Okay, channels has to be the last argument. So this is the beauty of core async here in this piece of code. It's all there. The composable abstraction, an abstraction that gives you means of composition. There's only one problem. If I'm writing here the pages on the channel, I will have again like 100 pages. What I actually want is a smaller resolution of results, right? So what I'm going to do here is replace this writing with onto channel. So the page is a collection of results. Every result is one movie. The onto chan will write each item of the collection onto the channel. So the resolution is different. Okay. So excellent. 435 pages for the query love. So that is 8,684 results. And let's see, I can ask here 435 pages. Let's see how long it takes. Only 5 seconds. And if you count the results, 868, I'm missing one. It means that I have to increment the last page, you know. Six seconds, 8,604. So you can look at this implementation. That is our async implementation. So let's compare the time it takes for 50 results, eight, a little bit less than a second, 100 result, 1.3 seconds, 200 results, 2 seconds, 300 results, 5 seconds, 400 results, 4 seconds. So that's what you get from using a clever abstraction that has an underlying thread pool that dispatches all the requests in parallel and manages the complexity of it all for you. So that's pretty awesome because if you compare again with find sequence, sequential solution. Say hi while we're waiting. Say hi. Yes. Yes. Say hi. Say hi. Say hi to the Clojurians. You want to say hi to the subscribers, maybe? Okay, so you see how long this took. 8 minutes versus 4 seconds. Sequential solution, 8 minutes. Concurrent solution, 4 seconds.